Okay, everyone, let's start this one. So someone asking something simple used to voltage difference between 2 point. Calculate XL at angle of 90 degree, V1 at angle of theta, V2, V1 at angle theta minus of V2 at an angle of 90 degree. Calculate XL like 2 pi FL. L is given, take F frequency is 50 Hertz for AC in India. Here you can use 230 cos 30 plus j sin 30. No, it is given only angle, not magnitude effect. If you take a magnitude, then there is no effect of 90 degree. Minus 230. What is your inductance? I think 10 millihenry. So 3.14 only. I think this one will be 37.91 at angle of 105 degree. Because of this angle is plus 90 degree for inductor. We take a 90 degree negative for a capacitor, then it will be active. Okay. This angle will be added to here. We calculate this one. Natural angle will become, this magnitude is only 37.91. Okay, this one is a 90 degree for negative, this one there only 15 degrees there. This is only this one. If you 90 degrees there, then there is only 15 degrees remaining. Then final answer your 37.91 at angle of 15 degree only. Not 105, 105 this one. Only I divided by the magnitude only. If you take a 90 degree of the air, this will be 15 degree only. You can see this is an current will be lagging up 15 degree of this voltage. Inductive, same thing. Inductive is the Simple, you can say na, the voltage difference of magnitude is this one angle up 105 degree. The angle I will be a 90 degree only. And there is a voltage lag, current lag is there na, between voltage and current. Is a lagging of 15 degree. This one is assuming the current, coming the current. Okay. I rough this one if you want. I think you note down, that's why I want to rough this one. Let's start for today's session. Today is the example of a PV system, application of a PV system for a grid connected. Where you want to connect to the grid or PV power. Then how can you connect? The PV system generates DC power. Then you can't be connect directly to the grid. First of all, then you should use a inverter, at least inverter to convert DC to AC. But there is a AC, there is a grid have some reference voltage or constant voltage. This is also known as the infinity bus, where is the voltage constant. Then how can you maintain that voltage also? And there is the frequency. If you talk about the India, there is a 50 hertz frequency. Then you should maintain the 50 hertz frequency, then maintain the voltage. Then after you can inject the current to the grid from a solar. One simple structure for converting this one PV panel to use an inverter, three-phase inverter. And there is a use of a transformer to step up of this voltage, the grid level voltage. Then this system is connected to the grid. There is a current and voltage. If we talk about the three phase, then simple use a three-phase transformer. Because grid have a three-phase system. VPB have a voltage of this one and IPB. If you want to MPPT, then first use algorithm for MPPT, then generate a reference for a current which one flowing through a phase in our inverter in our grid. Then there is a reference, you have requirement of a reference current. Then it means you take a VPB, IPB and use an algorithm for MPPT. Then it will generate three references for a three-phase current: IA, IB phase and IC phase. Same references given to the controller. Then controller generate PWM according to this to generate this current and feed to the grid. Then you observe this one, why there is a current only, why not a voltage for a three-phase system or a MPPT. You have requirement of voltage also. But you want to three-phase current difference from the MPPT, because you have a infinity bus, a grid have an infinity bus, there is a voltage constant like a DC, sorry, like a battery. Battery voltage is constant. Then if you want to feed a current or charge the battery, then you should control the current only, not a voltage. Voltage will be fixed if you connect to a battery or you connect to the grid. That's why there is a requirement of a current reference. Then how much current you want to feed there, because of voltage is fixed because of the grid there. Then current reference there per phase current. Then same current is tracking by controller. using controller. Suppose there is three phase system. Suppose there is a IA reference generated by this PV system MPPT. Then second one reference generated by the second and current flowing through a grid by inverter IA. And suppose if you have IA reference and a current coming from a grid side, have IA output of, sorry, then take this one, apply a comparator, then you have used the controller for a one phase, same thing for a three phase. IB reference, IB. Suppose we have used a PI controller, it is simple. Phase 1 PWM, or you can use this one constant generator, then after you use the PWM generator. This one give to the PWM generator. IC reference, IC. This will go to the PWM generator, generator PWM. Then after you can connect this thing to the inverter by using a gate driver. We tell this one you can use first a gate driver also. Then gate driver is connected to the inverter. There is 6 PWM for a three phase. Okay. This is a system. First generate uh, reference current from MPPT. Then after you use the comparator, compare to the output of inverter current. And there is a three phase system. You use a 3 PI controller for tracking a 3 current. But there is an issue to tracking this one. Suppose there is a reference current and this is the or output current, and the reference current should be started from 0, then output current is 0, then it PI controller can track this one and gives error of 0 because of PI controller used to reduce the steady state error. But suppose sometime if there is not enough phase, both are current is not in phase, then what happen? Suppose this current is flowing like that, start from here but your reference is here, then how can this track both? Suppose you want to track a magnitude but there is a differences between them, then how can you uh, minimize the error between them? Then there is a difficulty. That's why you, in this case you have to use a tracking PI controller, which one is more complicated to use. and you have a 3 PI controller. Then there is a problem to tracking this AC signal. Then how you can't be directly compare two signal to variable signal with respect to time and use a PI controller, any controller. There is some issues is there and some limitation also there. Then what is solution of this one and how you used to track this one? And there is a system which one convert this AC system to a DC system, equivalent DC system. Then this DC system with this DC system is compared to the algorithm given by this one. Same thing, it will also come converted into a DC system. Then that DC system it will be easier to convert easier to minimize the error. Sorry. Like a DC system, compare a constant current to a constant I reference to constant IA. Then you simply use PI controller, it will minimize the error in this condition. Then the transformation between AC to DC is transformed between two steps. First one is known as the alpha beta transformation. Then after alpha beta is also AC system. First to convert a three-phase AC system to a two-phase AC system. Then after you have converted and two-phase AC system to the DC system. Then this DC system, that DC system you can track and you can manage the errors a lot by easier way. And same thing used in modern way to implementing the controller in inverter or in drive to drive the machines motor, the, to controlling the motor speed torque like that. Then the same thing is used alpha beta transformation and DQ transformation. You know about the DQ and alpha beta. You can simply convert three-phase system to a alpha beta. Same, I use a three-phase system like A replaced by 180 degree, A, B, C. Then I have alpha beta system, alpha. Alpha beta is displaced by 90 degree to each other. So there is some vector, some magnitude, or something is R. Then what is the projection of R to the alpha side and beta side? Know about the projection. This will be suppose R alpha. This will be suppose R beta. Then we have simple AC system. Suppose in this case, if you want to calculate magnitude or of R reference with respect to the A, B and C, then how can you represent this one? I suppose this one will want to calculate. Suppose this one is an easier way to calculate the same thing from here, alpha. In alpha side, then we can calculate a simple way. If you want to calculate this A, it will be alpha plus beta, same thing. So what is the RA? Resistance. The RA is equivalent of this one is a 0 degree. RA at angle of this one with respect to the phase A of angle with of phase A is 0 degree. Then you simply use an angle way z theta, like theta is the angle between them. You want to calculate this one plus same thing, projection of beta on R, R on beta, like same thing, this one R on here. Suppose this RA, this one will be RB, RC, like that. RA equal to the RA with angle 0, because of this one is a simply impose the phase A, and RB is placed by a 180 degree and this one is placed by a 240 degree. Then simple you can use RB e to power of j 120 degree plus of RC e to power j of 240 degree. Magnitude of R with respect to the all three phases is RA plus RB. You know about R any or e power j theta is equal to R magnitude cos of theta plus j of R sin theta. Simply you can use here also RB cos of 120 degree plus j into RB sin of 120 degree. Same thing for RC plus RC cos of 240 degree plus j RC sin of 240 degree. Cos of 120 degree is minus 1 by 2, then it will be RB into, it will be minus of 1 by 2 plus j RB sin 120 degree root 3 by 2. Then after RC 240 degree, same thing, minus of 1 by 2 cos 240 degree plus j RC sin 240 degree is minus of root 3 by 2. These are two uh, imaginary part, 3 is a real part. Then combine the imaginary part 1 and real part at different time. RA, this is the real part, minus of RB 1 by 2. I take as a plus minus here, plus RC minus of 1 by 2. This is the real part, plus J RB into root 3 by 2 plus RC minus of root 3 by 2. Then you can break this one or magnitude in two terms, R alpha plus J or beta. You can take R alpha is this one, the real part, or beta is imaginary part. RB by 2 minus of RC by 2 plus J RB root 3 by 2 minus RC root 3 by 2. This is the alpha beta conversion of ABC. If you want to this thing, same thing in a matrix form, simple you can use in matrix. R alpha, R beta, just three variable RA, RB, RC. Then use here RA, RB, RC. Then magnitude of R alpha in RA, magnitude of RA in R alpha is 1. Then RB in R alpha beta, RB is minus 1 by 2, RC is minus 1 by 2. Then in the beta part, R beta part, this is this one. RA is 0 in this. RB is multiplication of RB is root 3 by 2. Then minus of root 3 by 2. A simple conversion of alpha beta. Sorry. Then same alpha beta you can convert in TQ also. Alpha beta is also variable part with respect to time. This is only two phase conversion system. Then these two phase conversion is convert into a constant magnitude and rotating at an angle of omega t with respect to time. If, like a sine wave, have omega t, there is some angle and rotating with respect to the time taken at an angle, and magnitude will be same. Then if you want to calculate the actual magnitude, then multiply by up. No, someone asking about the, no, not a DC. This is the AC system. No, this is the AC, two phase AC, not a DC. Or alpha beta has a two phase AC system. Then after if you convert this system to DQ system, then DQ system have a DC equivalent to DC. This system to equivalent to the DC system. Then after you can say this is the DC. This is the alpha beta same AC, two phase AC system. This magnitude is also varies with respect to time. Same thing if you want to alpha beta to DQ transformation. This that one is easier. You can take this alpha and beta part. Same two phase system. You can take like a DQ system. So D axis. This is a Q axis. Alpha beta between them have some angle known as the del angle, and this DC is a fixed. DQ axis is fixed, magnitude is fixed, and rotating angle is a delta, which is known as delta is a omega t with respect to time. This one gives some magnitude with respect to time, but the D magnitude is a fixed. Suppose there is a some vector R have a displacement of theta from alpha beta axis, alpha beta axis. Then you can measure the projection like R dq. You can say this one R alpha beta. Also, you can say this one R alpha beta axis. Then I converted this same thing here. Then what happened? What is the difference between them? A angle difference between them. A projection of alpha beta to the d axis. Simply if q will take as 0, then if you want to this one d axis, then what it this one will be alpha beta this magnitude, and angle difference between them is theta minus delta. Same thing, e to power minus of j theta minus delta, it will be del. With respect to axis, the angle difference between them is del only. If you take about the alpha beta, but if we talk about this one, is difference between them is theta minus of delta. And with respect to the alpha axis, same thing. If you want to know about the alpha axis wise only, this is the axis wise, alpha is there, and the angle difference between this axis to this axis is delta. Then you can simply use the minus of delta. It's a lagging of delta angle. If there is some magnitude, some vector is there. If you want to that vector convert into some value on dq axis, then you simply use the delta minus of theta minus of delta to impose the r vector alpha beta axis to the d axis, dq axis. If axis wise component is r alpha beta, so you can say this will be r alpha beta axis have some r alpha is there, and this is r beta is there, r alpha plus j r beta, then e to power of minus j. You can know about this one, which you cos del minus of j sin del. dq both are displacement between them is 90 degree. The same thing you can use rd plus of j rq, because of the 90 degree the j is okay when where difference between two axes is 90 degree only. That's why you can use directly j. So multiplication of this one and take imaginary part outside this one, or this one real part r alpha cos del, and if you multiply this j imaginary part to each other, this will be a positive of r beta into sin del, then plus j take imaginary part r beta of cos del minus, so r alpha, sorry, not alpha multiplied by the here, then r beta into cos del. If you want to convert in the matrix, then RD RQ. First write here R alpha, R beta, then choose the mm, multiplication of R alpha in DQ. This is the RD, you can say. This is the RQ. Then RD have alpha magnitude is cos del, multiplication of this one, and this one beta is sin del. For RQ, cos del. Oh, this is imaginary part. There is some mistake, I think. Imaginary part, if you multiply this one to this one, who get the real part. Multiply of this one, it will give the imaginary part. Then if multiply of this one, it have j r beta cos del. You multiply of this one to this one, give imaginary part minus of r alpha sin del. Same thing we will replace here, minus sin del. This will be a cos del. Then after you can use r alpha or beta to use the ABC. Can you simply use r alpha here? Okay, let's start a question. It will take a bit of time. Question first is given, let VR is 10 sin 100 pi t, or Vy is a 10 sin 100 pi t minus 2 pi by 3, and Vb is 10 sin 100 pi t plus 2 pi by 3. It will displace up 120 degree three-phase system with a voltage and stationary reference frame RYB that have R axis, Y axis and B axis displaced especially from each other by 120 degree apart. These three voltages are transferred into a DQ rotating frame which is rotating at a frequency of 50 Hz. Whereas the D axis is aligned along the voltage space vector. Then the value of Vd. Asking the value of Vd. Okay. The first calculate V voltage. I simply written a voltage. VR is equal to Vm sin omega t, simple sin omega t I have taken. Vy Vm of sin omega t minus of 2 pi by 3 or Yb Vm of sin omega t plus of 2 pi by 3. For alpha beta conversion or alpha, same thing, you can first convert into alpha beta, then after you can convert this alpha beta to the DQ axis. For alpha beta, R alpha have RA minus RB by 2 minus RC by 2. Simple, use here RA same to same, VR minus of 1 by 2 Vy minus of 1 by 2 Vb. Use a capital A, this one also. VR is Vm sin omega t, Vb minus 1 by 2 sin Vm by 2 sin of omega t minus of 2 pi by 3 minus of Vm by 2 Vb is sine omega t plus 2 pi by 3. Then you have to solve this one for V alpha. Vn sine omega t, take a Vm is common from all, then this will be sine omega t minus V minus 1 by 2 sine omega t minus V, sine A minus B you can use here, which one is sine A cos B minus cos A sine B. Then 1 by 2 sine A, sine it means sine omega t, cos B it means cos of 2 pi by 3. Then negative is there, then negative also here, the negative will be positive, half of cos is sine B, it means cos of omega t into sine of 2 pi by 3 minus same thing here 1 by 2 sine A cos B, there is a plus positive, sine A cos B plus cos A sine B, sine omega t cos of 2 pi by 3, then negative also negative 1 by 2 cos of omega t sine of 2 pi by 3. You can see here this will be half of cos omega t into sine 2 pi by 3, half of cos omega t into sine 2 pi by 3 will be cancelled out. Someone asked what is this one? Positive A plus B, it means sine A plus B. Sine A plus B is equal to sine A cos B plus cos A sine B. And there is a negative here, then both are negative. Sine omega t plus 2 pi by 3. Yeah, this is the B and this is the positive negative because of this are displaced by 120 degree to each other. Yeah, same thing, sine A plus B you can use sine A cos B plus cos A sine B, or you can use this one also. You can both, you can add by taking a 1 by 2 Vm common, then sine A plus B plus sine A minus B you can take. Then you can solve this one, 2 sine A cos B by 2 also. You can say solve this one by this one also. This will be cancelled out. Then cos of 2 pi by 3 is cos of 120 degree minus of half. This will be minus half. I written directly here. Minus half. This is also minus half. The minus half 1 by 4 1 by 4 here minus half. Then this will be a sine omega t. Minus will be positive 1 by 4 sine of omega t. Minus is positive plus 1 by 4 sine of omega t. Then this will be a Vm into 1 by 4 1 by 5 is 1 by 2 plus 1 is equal to 3 by 2. Okay, so 3 by 2 Vm sine omega t. Next one for a beta. Same thing used for beta, V beta. You can use this one. V beta is RA 0, RB by root 3 by 2 minus RC root 3 by 2. 0 plus of root 3 by 2 Vy minus of root 3 by 2 Vb. Then root 3 by 2 Yb have Vm, take a common. Vy is of sine omega t minus 2 pi by 3 minus of sine omega t plus 2 pi by 3. You can expand this one also in terms of sin A cos B cos A sin B. Same thing you can result to will get sin omega t into of cos 2 pi by 3 minus of cos omega t sin 2 pi by 3, then minus this one sin of omega t cos 2 pi by 3 minus of cos omega t to sin 2 pi by 3. Then this one will be cancelled out. Sin omega t sin 2 pi by 3 is root 3 by 2. Same thing here, root 3 by 2. Now root 3 by 2 cos omega t, root 3 by cos omega t. It will be root 3 minus minus will be minus of root 3 cos of omega t. Final will be same minus of 3 by 2 Vm cos omega t. This is the V alpha. Sorry, V beta. Then after you can use simply VQ Vd. V alpha of cos del plus V beta of sin del then VQ V alpha minus of sin del plus V beta cos del. And V alpha is 3 by 2 Vm sin omega t, 3 by 2 Vm sin omega t into cos del plus V beta. Beta is minus and take minus 3 by 2 Vm cos omega t into sin del. Same thing here, minus of V alpha. V alpha is 3 by 2 Vm sin omega t into sin del. Then V beta is minus of 3 by 2 Vm cos omega t into cos del. Beta you can common 3 by 2 Vm from both. Then what is the remaining? Sin A cos B minus cos A sin B. It means sin A minus B. Omega t minus del. Same thing for VQ. Minus of 3 by 2 common. Sin A sin B plus if you take a minus outside cos A cos A. It means cos A minus B. Okay, so asking the question is VD, VD is asking. Then the three phase 50 hertz is where it is aligned to the voltage space vector. Its frequency is given 100, 50 hertz, same frequency. You know omega t is del, and frequency is given 50 hertz. Then 2 pi 50 into t is equal to 100 t. Sorry, 100 pi t. Del is equal to 100 pi t. And omega is also given as 100 pi t at starting. You can see here. Then take both are 100 pi t. Then what happened? 3 by 2 Vm sine of 100 pi t minus of 100 pi t. Then what will be? Sine A minus, or this will be sine 0. Sine 0 value is 0. Minus of 3 by 2 Vm cos of 100 pi t minus 100 pi t. 0 cos 0 is 1. It means minus 3 by 2 Vm is the Vq. Then you can say Vd is equal to 0 and Vq is equal to minus of 3 by 2 Vm. Then what is the Vm? 3 by 2 Vm is in the question 10. And take a 10. This will be a minus of 15. Vd is 0, Vq minus 15. It is asking about the Vd. And Vd is 0 in this question. Vq is minus 15. I think this will be a next question for Vq. Yeah. The next question is given same question. I have a 10 sine of pi t, 100 pi t, V by V with the voltages stationary reference frame R by B that have the R axis, Y axis, and B axis displaced successively from each other by 180 degree apart. These are these three voltages are transformed into DQ to rotating frame, which is rotating at a frequency of 20 hertz. Whereas the Q axis aligned with the voltage space vector, then the frequency of the signal in the DQ axis frame. Asking about the frequency, I mean DQ axis frame. It means omega t. If you find omega t, then you can compare both and find the frequency. Yeah, same thing. D axis and Q axis can calculation both are the same. Take a 90 degree apart only. This one, if a VG is in this is the D axis, Q axis. If these are along with D axis, or you can along with the Q axis, then one part is 0, one part is remaining there. That's why same thing. Question number here is asking about the frequency the Q axis along with the space vector. That's why one part is 0. Same thing here also. If you along with the Q axis and Q is remaining part, T is equal to 0. That's why there is a Vd is equal to 0. That question, previous question, because of the Q axis is along. Then Vq only present is there. If there is a Q D axis along, it means Vd is present only. Vq will be 0 in that time. If there is a not along with any axis, then Vd and Vq both are present. Okay. I have taken same question from previous question. Vd is equal to 3 by 2 of Vm sine 100 pi t minus of theta del, you can say, and Vq is minus of 3 by 2 Vm cos of 100 pi t minus of del. This 2 is coming from that. Same because of there is the same q axis along. Is given a 20 hertz frequency. Then what is del is omega t, and 2 into pi into f is 20 into t. Then del is equal to omega t, it means 40 pi. And the frequency of the signal in dq axis frame. Then what is frequency of any signal? You can take any one, both of them. You would take a VD, or you can take any one, because the both frequency is same. You can say here frequency will be not difference between them, different, both are same frequency. This will be 3 by 2 Vm sine 100 pi t minus of del is 40 pi t. And what is this one? 3 by 2 Vm sine 60 pi t. From this one, we know about this is the frequency, represent the frequency. Then what is the frequency of d axis? Axis frame, rotating frame. Same thing, 2 pi f omega is equal to 2 pi f dq. Then 60 pi divided by f 2 pi. Thirty hertz. Frame will be rotated at a 30 hertz. Because of d and dq axis, frame will rotate. Magnitude will be same. Okay, take the next question. Let the Vr is 10 sin omega t, then same sin 100 pi t, Vy sin 10 sin 100 pi t minus 2 pi by 3, and Vb is 10 sin 100 pi t plus 2 pi by 3. With the voltages in stationary reference frame RYB that have the Rx, R and YB axis especially from each other by 120 degree. These three voltages transform into same DQ trans rotating frame which is rotating at a frequency of 50 hertz, where is the q axis is aligned along the voltage space vector, then the value of Vq. Same in the previous question. Already I think find Vq. This one 3 by 2 Vm minus of 3 by 2 Vm will be 10 and overall 15 minus of 15. Okay. Referring the question number 1, same question, if the three voltages are transformed into two phase stationary frame alpha beta, with as horizontal axis and as vertical axis, we know about alpha beta. So alpha beta, this will be a horizontal axis, this will be a vertical axis. Then the loci of voltage space vector in alpha beta frame will be, now this one RYB have same stationary frame will be a same stationary, and alpha beta also is stationary, only magnitude and angle will be changed with respect to the time. Then suppose there is some value or a vector, then what happened, and sometime it will be rotated. like that. Magnitude will be changed here to here, and angle also change. The center will be a 0 0, and makes a circle. Then what is the radius? Radius of the circle is same 3 by 2 Vm. Magnitude of circle, it means magnitude of this one, maximum magnitude of this one will be 3 by 2 Vm. And cos omega t, if you rotate it of this one, then magnitude will be changed. The maximum magnitude is this one. Then this is the radius, because the magnitude vector is this one, 3 minus 3 by 2 Vm. Same thing 15, and makes a circle center at 0 0. Yeah, same thing. A circle with a center of 10, no, 10 is the magnitude of a 3-phase system, not a 2-phase system. If you convert this one 3-phase to 2-phase system, the magnitude will be 3 by 2 Vm, 1.5 times that one. An ellipse with a center at 0 0, major axis and minor axis length is 10 and 50. No, this will be same, because our omega t is rotating. The same time, the magnitude will be maximum with this one only. Because you can see in the question, when only calculated the alpha beta, both magnitude is same in the both axes, minus 3 by 2, 3 by 2 Vm. Only the negative part is there, but magnitude will be same. That's why there is not an ellipse. If the magnitude is difference between them, V alpha and V beta, then there is a making a ellipse possible there. But in this question, is both are the same magnitude, but sign is changed, direction is. Okay, that's why it will making a circle. Same thing, left side 0 0, major axis major. No. Okay. Now the next question. Oh, it is a second question. In a single phase transformer, turn ratio of 1 tends to 1, it means isolation transformer. It will 1:1 ratio is used in isolation transformer, where you use the isolate a two circuit. Sometimes some circuits have a requirement of isolation. That's why they to separate two circuit by ground, the common ground. To if you don't want to a common ground between two circuit, and if you want to the output side is not affected to the input side, that time you have used the isolation transformer, like a gate driver of MOSFET and IGBT. There is a requirement of isolation transformer also. And sometime in communication between two channels, then there is also used of the isolation transformer, which will ensure the uh, isolate between two circuits. If any circuit have some damage or some fault is there, then not affected to the another circuit, because of both are the isolated. Okay, the turn ratio is the same. Transformer is sorted. Is given primary of the transformer is sorted, and the inductance measured from a secondary side is observed as 1 millihenry. We transferred all of thing in a circuit. Okay, LS1 has a is the primary leakage inductance, LS2 is the secondary leakage inductance, and LM is the magnetizing inductance of transformer referred to the primary side. It means output side is referred to the primary side also, which is the following statement is true. A transformer, simply if you neglect the resistance, it will be looks so equivalent circuit diagram like that. And this will be LS1, this will be LS2, magnetizing inductance. In the question given, the primary side will be short circuited, and secondary side L equivalent is given as 1 millihenry. Then will be asking about the statement. Okay, then first calculate this one. You know about both are connected in parallel, then connected in the series. The simple you can use series parallel combination. ls2 plus ls1 parallel of lm into lm divided by of okay. In this case, we take a common of both sides is lm, then what happen? ls2 plus lm common ls1 count both side of ls1 divided by f lm plus 1. Then you cancel out, it will ls2 plus of ls1. You know about the magnetizing inductance of a transformer is very higher than the leakage inductance of transformer. This is not the primary inductance, this will be a leakage inductance of transformer. Also mentioned here, and you know a transformer circuit, equivalent circuit, there is an inductor in primary side and secondary side that are leakage inductance of transformer, not the primary winding inductance. There are two inductance. In if you uh, take a winding and to a core, use a core and winding them, then there is a inductance of this core of this winding. Then there is some two. There are two inductances there. And transformer, if you talk about the transformer, there is a leakage inductance which will not transfer to the secondary side. It means this will not linkage to the link to the secondary side. To link only primary side, the leakage inductance. Then there is the primary inductance. Is the different thing. The primary inductance you have used to determine the voltages. You know about the yes, some voltage E is equal to n d phi by dt. Same thing you can use as a L dA by dt. This is also voltages in inductor. This also voltage in induced EMF. Then same things will be linked to this one, and this will be referred as the induced EMF in transformer. That's why there is a note mentioned in the circuit is a primary winding inductance. There is a mention only a say leakage inductance. That's why leakage inductance is very less compared to the magnetizing inductance. Approximately, if you talk about the leakage inductance, will be a 2 millihenry or 1 millihenry only, and the magnetizing inductance it will be more than the 500 millihenry. That's why you can neglect this term. Then you have get the equivalent is ls2 plus ls1. An equivalent I have given is 1 millihenry. Then both are as insulation. This is the isolation transformer. It means 10 raised to 1 times to 1. Then you can say both inductance is same. In this case, both are 1, 0.1, 0.5, 0.5 and 1. Not 1, this one. Because of equivalent inductance is given 1 million. Okay. In a grid connected application, in order to track a regular position of a grid voltage using a PLL, then which of the following is done? Q axis component of grid current reference is set to 0. Projection of grid voltage space vector along b axis, beta axis of the stationary reference frame is used, or d axis of a synchronously rotating frame is aligned with the grid voltage space vector. Last projection of a grid voltage space vector along alpha axis of the stationary reference frame is used. For a PLL is simply used to find a frequency and angle between them. There is a requirement of an angle for converting the alpha beta to DQ, or ABC to DQ alpha beta. There is a requirement of some angle. That angle we will find from a PLL, phase lock loop. Then this is eventually used to voltage, not a current, because of the current may be have some harmonics contents in a current. Then there is some differences between angle also, and the frequency maybe frequency will be same, but there is some distortions there. That's why you used a voltage reference only. Take a voltage reference and find the angle of this that one. Then how can you find the angle of the voltage only? If you have alpha beta and a dq axis is there, suppose you have some voltage space vector Vg and some Ig is there. By controller you can use to element any one. Ig is equal to 0, Ig q axis, and Ig Vgq. To neglect this one, if you do this one thing, then you can say Vg will be equal to the Vd axis, Ig also is here, Vg d and Igt axis only. This will be 0. There is not Vg. Vg q axis will be 0, Ig q axis will be 0. But to find the PLL, we have used this voltage along with the D axis only, and simply measure the angle between them. This angle, same thing, this angle will be this one, theta. You can measure simply, and by controller you can neglect this one 0. That's why the frame in this question, q axis component of a grid current reference is said to be 0. This is said to be 0 for finding the unity power factor. You can also see here, suppose this both quadratic axis is 0, then what happened? Only Vg and Ig is there. Then what is the voltage difference between them? Angle difference between them is 0 degree. Then cos phi is same thing. Voltage angle difference between the current and voltage 0 degree. Cos phi is 1. It means unity power factor. To find the unity power factor, you should use this one. That one will be 0. Then simply it will be in phase of voltage. That time it will be used. Then projection of a grid voltage space vector along beta axis of a stationary frame. No, be not a beta, it is a dq only, not alpha beta. A d axis of a synchronously rotating frame is along with the grid voltage space vector. Yeah, same thing. Vg, this will be along with this one. Okay, so yeah, this one will be same page. for finding the angle, position angle by PLL. This thing is used. Yeah, in a grid connected application, if the grid voltage source vector is lying along the d axis, then the order to inject the power at the unity power factor into the grid, then which of the following is done? Yeah, same thing as the next question. A q axis component of a grid current should be 0. Yeah. If q iq is 0, then what meant? id and vd is in same phase, then power factor will be unity. D axis component of grid current reference factor, no, this will be 90 degree, power factor is 0. D axis of a sequentially rotating frame is along with the grid voltage space vector. Yeah, this is also used, but this is also already used. That's why the preferable is this one. Q axis of a no, this one not used. DQ transformation is applied to a set of balanced time varying three phase voltage at the fundamental frequencies. The voltage has fifth harmonic component in it. Then after transformation of DQ axis, the D axis component will be, yeah, D only DC, or DC plus fifth harmonic, or DC plus fourth harmonic, or DC plus sixth harmonic. You know about DQ transformation? A three-phase system you transfer to the DQ system, and there is a constant voltage which is known as a DC voltage. Same thing is asking here. If suppose there is some harmonics contents is there in three-phase system, then that harmonics contents apply. If you want to DQ axis, then there is some harmonics is also present in DQ axis, or it will be a same thing, 0. Only DC is given. This is asking that. Then how we will get this one? Same thing. Find the first set of three-phase balance system like VR is equal to Bm sin omega t, Vb Bm sin omega t minus up to pi by 3. Oh, sorry. Byb na. Bm sin plus up to pi by 3. This is the balance time varying three phase voltages. But the voltage has a fifth harmonic component. Then what happens? Simply add fifth harmonic component also here. Add this one, fifth harmonic here. 5 omega t plus Vm sin 5 omega t minus 2 pi by 3. Then take this one and apply alpha beta. Then go to the DQ axis. Then we will get the final answer. And for alpha beta transformation, V alpha you know about the VR minus half of Vy minus half of Vc. So Ry, so Ryb Suppose you have already calculated this one, this part, then you can leave this part and directly you can return. Then after you used this one, because of this was the positive sum of this one, then simply use this one. Vr is a Vm sine phi omega t. So easy to find because of this one already find minus 3 by 2 Vm minus of half Vy Vm sine 5 omega t minus 2 pi by 3 minus of half Vm sine 5 omega t plus of 2 pi by 3. Same thing sine a plus b, you can open this one. Sine 5 omega t into cos of 2 pi by 3 to not a 2 pi because of 5 multiplication is there, then 10 pi by 3. Then minus will be positive half cos of 5 omega t into sine of 10 pi by 3, then minus of half sine 5 omega t cos of 2 pi by omega t minus of half sine, oh sorry, cos, and this will be a cancel of V alpha is Vm 5 omega t. If we calculated this one constant pi by 3, this will be same uh, minus 1 by 2, and same thing this, oh, this will be 10 after 2 minus 1 by 2, minus minus will be positive, positive positive, plus of 1 by 4 sine 5 omega t plus of 1 by 4 sine 5 of omega t. Then V alpha is equal to Vm same 3 by 2 Vm sine 5 omega t. For this one, okay, I have used 5 for a fifth harmonic. Then total V alpha will be a 3 by 2 Vm sine omega t plus 3 by 2 Vm sine of 5 omega t. And V alpha is equal to 3 by 2 Vm something you can apply for a V beta. 5 first calculate the 5 because of we have already calculate beta for 3 same 3 by 2 minus of 3 by 2 Vm cos omega t. Beta is equal to 0. First V is 0. R V root 3 by 2 Vy minus of root 3 by 2 Vb. Then root 3 by 2 Vm will be common. Sine of 5 omega t minus of 10 pi by 3 multiplication of 5 sine 5 omega t plus 10 pi by 3. Same thing if we calculate this one root 3 by 2 and total V alpha V beta 3 by 2 Vm sine omega t plus cos omega t same thing here you can say. So this will be negative of minus 3 by 2. This is the doubt of this one, not a positive. With a negative V alpha and V beta. And Vd, you know about Vd, V alpha cos del plus V beta sin del. From this matrix, that is starting with this conversion for Rd, R alpha cos del plus R beta sin del, and for D R dk Q RQ R beta cos del minus of R alpha sin del. Then the question asking about the Vd, the d axis component in Vd. Take Vd V alpha is 3 by 2 Vm sin 5 omega t into cos del plus V beta will be minus of this one minus of 3 by 2 Vm cos of omega t cos of 5 omega t into sin of del. 3 by 2 Vm you can common, sin omega t cos del plus sin 5 omega t into cos del, minus will multiply here, then cos omega t into sin del minus of cos 5 omega t into sin del. You can see there sin a cos b and minus cos a sin b. Then Bd is equal to 3 by 2 Vm sin omega t minus of del. Another one sin a cos b minus cos a sin b. It means plus of sin 5 omega t minus of del. Then the question given three same fundamental frequency, it means you can say delta is equal to same omega t, same rotating at the same frequency, fundamental frequency, then delta is equal to omega t. Then put the value of delta is equal to omega t, then find the degree. You can see here for the fundamental frequency, the Vd, if harmonics is not there, then this will be 0. Sin omega t minus omega t, sin 0 value is 0. But here is some frequencies there. This is not a pure DC if harmonics is including there. Then this will be a sin 4 omega t. If the harmonics is there and the frequency is not the same at the rotating frequency of a rotating frame, frequency is not the same frequency to the AC frequency, which in three phase AC system, then there is some harmonics is there. Same thing if the frequency is not same anywhere, then you can see this is sin omega t minus del. Del is not the same frequency at omega, then there is also some magnitude and some variation is there in Vd. Vd is not pure DC. Vd is pure DC. It's same if the same frequency is rotating frame as the three phase system frequency. Then Vd is equal to or constant DC voltage 3 Vm 3 by 2 Vm. But if there is some harmonics is there, then you can say this is the DC system, some DC plus fourth harmonic. Here is equal to here is a 0 because of I taking as a q axis as the reference of q axis. That's why Vq is present and Vd 0. Because of here I taken as Vr is a 0 degree something. If you take some angle, we not equal to the here the alpha beta. If you taking alpha beta is there after converging of Vd, not the same axis as the beta axis, then there is some voltage also there. Okay. And there's a next question. The following statement indicate the characteristic of the power semiconductor switches that are used in the inverter circuit. Which of the set of a characteristics are necessary and sufficient? First one, bidirectional current carrying capability. Second one, bidirectional voltage blocking capability. And third one, the unidirectional current carrying capability. Fourth one is a unidirectional voltage blocking capability. Is asking about the which one is necessary and sufficient thing you in the switches you want to properties of switches, then you can use in your inverter system. Inverter simple, you take a circuit of inverter. Suppose there is some load, I take an ABC. A connected here, B connected to here, C here. First one, you have to trigger the system by your own choices. Like when you want to operate the switches, S1, S3, S5, S2, S6, and S4. Then you need to AC system. It means you can't be directly get the AC system by using this thing. But if there is some likely AC system like that, then you can say you can convert this one to the AC system by using a filter. I written here. Likely if you convert this system like that, suppose, then if you use a filter, then you can convert this will be in AC system. Then you have to trigger the that switches like that, then you find the voltages in this manner. If you find the voltages in this manner, then after you can convert this one into your AC system by using a filter. Then there is your choice to operate the switches according to your desire. Then it means you have to switches, then that one have definitely have a blocking capability. Suppose there is a not blocking capability in the switches, then all switches is operated at the same time, because of positive connected here and negative connected here, then maybe it will be operated. That's why it should block the voltages at least one sided. Okay, another side is not blocking. Why not blocking? I just explained. Wait, but it will be at least one current rating. Current will be flow that side. It means okay, positive direction. Negative direction is required by flow of current. Let's assume first in suppose this switches and this switches is turned on. Sorry, this one is turned on. Then what happened? Current is flowing like that. Make a path AB, voltage AB is there. AB is fine. Okay. VAB is fine. This voltage, okay, C voltage 0. Now you can take a phase wise voltage is VA, VB, VC. VA is VDC by 2 because of these are two connected in series, two leg, two arm you can say connected in series. Then VA is equal to VDC by 2, VB is equal to VDC by 2, like that you can say. And then sudden suppose you off these switches. If there is a resistive load, suppose there is a resistive load, then what happen? Current will suddenly 0. There is no problem. Current will be 0. You will switch off this one. Another problem is there. In the switches, you can see the both switches is connected in a manner in a series like that. Then suppose both the switches is turned on at the same time, any particular time of moment by a delay, because of the practical switches it can't be turned on in my 0 second. It will take some time, like a delay time, to turn on and turn off. Then at that time, that moment, if you suppose one is turned off and another is turned on, there is some meeting point is there. At that point, it may be damaged the source, or it might be short circuited the source. That's why there is a requirement of some delay between them. One is purely turn off, then after second one will be a turn on. This will be flowing like that. Then suppose there is some delay and you have inductive load, the inductor current sudden should not be 0. Then you have to provide some path to discharge the remaining current of inductor. Then how can you charge this one? Suppose you turn off the switches and you want to still current flowing same direction because of the inductor. You can't be disconnect this one. Then same current will flow by using a diode. Diode is required for this one only. Then current will not directly flow here, then current is flowing from this path, from this path. Make a circuit and current is flowing to the back to the DC system. That's why there is a no blocking capability at the opposite side direction. There is a no blocking capability. Should not have blocking capability because and current capability is flowing current is it will be bidirectional and single blocking capability, not a both blocking capability. If you block the both side, then there is a problem of flowing a return path of an inductor when switch is turned off. Then this type of switch is used in your inverter. Then blocking capability is one side and current flowing at both side. Then take as option like then the bidirectional current carrying capability, yeah, was is fine. Bidirectional blocking capability, no, this is not required to block this one because of there is a inductor current flow is by own minor, not your minor. Then you have to provide some path of them. Unidirectional current capability, no, unidirectional current capability is not required because of there is a requirement of bidirectional current capability because of the current flowing of a to flowing the inductor current. Unidirectional blocking capability, yes, this one is voltage blocking capability at one side. It means like that. V I and blocking capability is showing this one voltage. Current is flowing at both sides, but there is not blocking capability at opposite side. Reverse bias. It means only 1 and 4 is capable. You can't be block the same thing both sided. That's why you can, I think you see your circuit, practical circuit, there is some uh, diode is present. The MOSFET is okay, MOSFET have some body diode, but IGBT has not body diode. Then a manufacturer also provide another diode with IGBT in some cases. In some cases, if there is not a diode provided by the manufacturer, then you should have, you, you have to add some diode or diode, sorry, so add to a diode antiparallel to the switches to flowing the current return path of a inductor. If there is no inductor, only resistive load, then there is no requirement of a diode. But if a negative inductor is present in your load, then there is a requirement of a diode to provide a return path. So, okay, the output of an inverter is connected to a grid via one and to one transformer. The equivalent circuit of a transformer have a leakage inductance of 1 millihenry, both primary and secondary side. Then there is a transformer 1 ties to 1, same thing like that. The magnetizing reactance of transformer is 100 millihenry. Magnetizing inductor, not the reactance, this is the inductance. LM, LS1, LS2. There is an input side, there is a grid output side. Then the impedance in between the inverter and grid. There is an inverter, there is a grid. Approximately, then you can simply disconnect this one, because this is a very high impedance provided to the circuit. Then you can add simply this one. Both are the sum of this one. LS1 plus of LS2. Or you can sorry, you can transform this one at you know about star delta transformation. Yeah, only this one present in the picture. This will be a parallel to the here inverter side. This will be a grid side. Then between them only a this resistor LA. Suppose LA. Then you can calculate LA by using a sum of this one LS1 plus LS2, multiplication of this that one LS1 plus LS2, divide by of remaining one LM. Same thing, this will be very high with respect to this one. You can neglect NS1 and LS2 is there. This is the 2 millihenry, 1 millihenry is each. Okay. The question also given 100 millihenry and 1 millihenry. If you multiply by 1 into 1 divided by 100, then this will be a 10 to the power minus 6. This will be a 10 to the power 3. This is very low. That's all. Okay, fine. You want to stop here. Okay, thank you all. The remaining part we will discuss in the next lecture. Thanks to all.